Days ago, I was sitting at home enjoying summer, preparing myself for a new year of suffering at school, and then it happened. On one of my videos, a subscriber commented and he suggested for me to solve a problem. The serenity and the peacefulness of my summer break were over, and now I trembled. He said he solved this question, and it's the most beautiful question he has ever solved. I shaked because I didn't know. Maybe I couldn't solve this problem, and my YouTube career would be over. So I didn't respond immediately. After a day of this thought coming to me in my nightmares, I decided and replied to this guy. Said, sure, bro, love it, send the problem. To which he responded and sent me a problem statement. And then he said, good luck and enjoy, as if I'm going to solve this question. But yeah, today I'm going to attempt to solve this question together with you guys, live streaming, just like my first videos. I'm nervous because I might not solve it. This video might take 2 hours or 4 hours, but one thing I know for sure, I won't stop until I solve this question. So wish me luck, and thank you to Simmons 2006 for recommending this problem. I know this is a bit unusual intro, but it is what it is. I just decided to make something interesting today. So yeah, let's see what's the question about. And thank you everyone for 1,000 subscribers. Guys, this really means a lot to me. I really appreciate all of you guys, and I've never expected to get that many subscribers in such a short period of time. And it's all just purely because of you. And I just wanted to take my time and say thank you to all of you guys because it really means a lot to me. And when I started this YouTube channel, um, I planned, my plan was to essentially um, get only 500 subscribers by the end of the year. And we already have double of that, and we have like in the half amount of time. So I just wanted to take time and say thank you to all of you guys for all the support that I received in the comments and in the DMs. This really means a lot to me, and I'll try to continue make good content for you guys to enjoy and improve. But yeah, let's start the problem. So we have O being the circumcenter, I is the incenter, and the exterior angle bisector by the vertex A intersect line BC at D. Okay, so I did already draw the incenter because I saw I and O. So let's draw I, and then let's draw O. Okay, yeah, so first of all, we already see that the problem is a bit not that traditional because usually you don't have both I and O, it's usually or one or the other. So at some point we'll have to decide uh, what we want to do. But as a general advice, I would say when you have problems I and O, the I point is mainly the good one, and the O point is mainly the one that makes everything bad. Yeah, but again, this is just my thoughts because I need to, keep yapping, or you'll just click off. Um, yeah, but let's continue. Then we have line BC intersect at point D, and you can, you know, I don't want to make you listen to all of this stuff, so you can feel free to skip like 10 seconds and continue watching later. But the other thing that I'll say is like, usually when I even talk something behind the lines, I don't talk some random stuff. I always try to make something interesting. So then we have I be the circumcenter of AX circle. Okay, so far pretty standard stuff. Nothing interesting. Let's see what Mr. Simmons 2006 got to offer me. Okay, we have point O. Let's read what happens next. Okay. Let k lie on AI such that AK equals 2AI equals is less than IK. Oh gosh. Oh my goodness, this is ridiculous. Okay. Yeah. Yeah, that's why it's probably hard. Okay, so we detect the problem now. Uh, the problem is we have a very, very goofy point K. Again, what do we need to prove? Prove that df is the diameter of circle dk. Okay, I remember what's happened. We can delete that and just focus on solving this question. Okay, okay, time to log in. So let's log in. We have ABC, IO, then we have a point D, which is the external bisector, and then we have basically reflected this and this, which is already pretty terrible. Like, oh my goodness, I've never seen this in my life. And then the problem said you need to take this line, right? That's the bisector, and we take the circle DKIA, Jesus, and we take its diameter DF. Oh my goodness, this is just who came up with this? Oh my goodness, bro. How high do you need to be? Alright, so finally, um, okay, yeah, point F here, and we need to prove that FO equals 3OI or something like that, right? OF equals 3OI. Okay, so that's our problem. Let's start solving it, I guess. Okay, so first of all, I assume IOF is collinear. Okay, that's great. Great to know. Here's the first thing. The second thing is, so the second thing is we have these X circles. Like IA is kind of hanging in the air. And the other thing is that we have this line IO. And the cool thing about IO, it's actually the Euler line for like a lot of circles, for a lot of triangles, like the tangency point triangles, and also for triangle IA, IC, IB. And I think in this case, the first step that I'm going to do is I'm going to actually add the excenters, IB and IC. So I usually call it the excenter trick. And what excenter trick essentially is we try to restate the problem for triangle IA, IB, IC, like this, and see what happens there. Okay. Okay. My goodness. Yeah. So we have this. This is a trick that's used a lot when you have like one excenter, but also like the problem can be defined very well against IABIC. In this case, it's much better than against ABC for the reason that essentially, if we reflect I about O, we'll get a point called Bevan point for triangle ABC. It's denoted as BE. And what's good about the Bevan point? Oops, it's the circumcenter of ICIBIA. The reason is for triangle IAIBIC, so let's just flip it around. Uh, this, yes. Um, yeah, you think that's good enough? Or no? Should we? Yeah, I think we should tweak it up a bit. Let's just make it a bit more normal. Okay, that didn't take that much effort. So we flipped our diagram, and now essentially from here, let's see what's actually going on. We have a triangle IAIBIC, We have three heights, IBB, ICC, and IAA. They intersect at the orthocenter I, and you have O being the Euler circle center because ABC, the circumcircle is the Euler circle, and we know that Euler circle is the midpoint of HO, where O is the circumcenter and I is the and H is the orthocenter. So if we reflect I about O, BE, Bevan point, then Bevan point must be the circumcenter of IBIC. And then we reflect essentially now what we have to show is that if we reflect I about the Bevan point, then this point will be on the diameter of this circle. And what I usually advise people to do in these cases is to not leave IAIBAC because that just doesn't sound nice, and just come back to normal notations. So what I usually do is just draw a separate diagram, but just mm, to the like my uh, moral uh, struggles with wasting so much of your time. Uh, I'll just speed up this process for you guys. So yeah, essentially, here's what's happening, and now I can use normal notations because I'm also not just solving, I'm explaining this for you guys. So I'll try to keep my notations tidy so that my what I mean is clear. So here now, essentially, we don't need these two lines, and now we have our final problem. And another thing is we don't want the diameter dh prime to be the definition of dh prime. So my final statement of how I want to treat this problem is next. We have a triangle ABC. We have H being the orthocenter, O being the circumcenter, H prime is the reflection of H about O, and then B1, C1 are the foots of heights, HA1 to A1K is 1 to 2, and I want to show that DK prime and H prime A D, both of these angles are 90 degrees, so that's much better. Okay, first of all, K is the work point, obviously, so right now, let's just focus on showing that this angle is 90 degrees. Okay, this will be a bit tricky of making all these points look nice. I will do it for you guys though. Uh, uh, Jesus, why is it so hard? Oh my goodness. Yeah, guys, this is getting out of hand. It's harder than it looks. Okay, this is a bit better. So we're trying to show that this is 90 degrees. And the thing is, when you talk about 90 degrees, there's kind of like two ways to approach it. A more standard way where this angle is kind of countable, or some quadrilaterals can be cyclic. But in this case, I don't see any possibilities for the reason that the only cyclic things you could get that use 90 degrees would be something like BHH prime, and the angles don't count up nicely here. So I abandoned this idea. So the other way actually is to like think about more of like vector approach. So we trying to um, say, oh, we always in geometry, we're always trying to kind of like rephrase some statements. So what statement I want to rephrase is either I want to find a line that's parallel to a D or a parallel line to a H prime, and then like finish up from there. Uh, yeah, I think there is a nice thing about. So D, there's a nice lemma about point D. So if we take the circumcircle of our triangle ABC, there's a very, very famous lemma. And the lemma is that if you take this intersection Q, then we'll get that angle AQH is 90 degrees. And this is true because of, I think, radical axis. Uh, So we take the circle on diameter BC, circle on diameter AH, and we're done. This is the radical axis for these three circles ABC, circle on diameter AH, and circle on diameter BC. And if this 90 degrees, now we just want to show that QH is parallel here. And yeah, I think I see how to finish it. So the way we can finish that is there's this lemma that in a right angled trapezoid, the midpoint is equidistant from the midpoint of like a side length is equidistant to two vertices. So here we actually do have such a trapezoid that should be, well, we don't know that these are parallel yet, but we do know that this thing, so here we have AOQ, and this is an isosceles triangle, and H is a point such that HQA is 90 degrees, and then reflect H about O, and we get point H prime, and we want to show that H prime AQ is 90 degrees. This is true because if we take the midpoint of AQ, point M, then we get that MO is perpendicular to AQ because it's the height in an isosceles triangle. And therefore, we reflect QM to MA, HO to OH prime, OM is parallel to QH, so AH prime is parallel to MO and parallel to QH, so the first part is done. Okay, we're done here. And yeah, that's nice. But this was the easier part in the problem because H prime is more of a well-defined point than K. So K is the real horror in this problem. I still have not much idea how to approach it. So yeah, let's think about what we want to do here. So this is the part where I'll probably get stuck for about an hour or so. I don't know. But yeah, we're trying to show that this angle is 90 degrees. That's our goal, and then we're done with the problem for obvious reasons. Uh, okay. So the reason why this is not, I'll just adjust my camera so you could see my pretty face. Okay, the reason why it's a bit stinky is because this is 1 to 2, so it's a bit random. But obviously we have to mark this point. So let's mark this point N. Oh my goodness. Point N. Why do we need to mark this point? Well, for the simple reason that this is equal to this and equal to this. Okay, now again, we have two choices. We can look at angle chases or we can look at parallel lines. So we're trying to find probably a parallel line to H prime K or to DK. I think the more logical one to search for is H prime K for the reason that if we look at H prime K, we have ratios on this side and we have ratios on this side. So it's pretty nice that both ratios come out. And for example, by Menelaus, if we reflect H prime about K, it's sufficient to show that this point is equidistant from H prime and this prime, and it's also lying on this line by Menelaus. But yeah, I don't think DH prime is the best. If you look at the circle, does anything around this circle? Yeah, I don't think so. I just think DH prime is, and especially this DH prime is very, very weird. So no, I don't think that's the best way. We have to find the line that's parallel here. That's parallel, and then to show that it's going to go to DK. We do have ratios here. O pass through midpoint. Maybe this line would be better. But again, I don't see where it's better because, well, the only way it's better is kind of this point, maybe. It's the midpoint of A1D, which is not that bad, but also not that good. Yeah, it's not that good. So yeah, I think H prime K, we need to find a line parallel to that, and then try to do something. But the other thing I'm looking at right now is the definition of point D. So in my ideal scenario, I don't want B1 and C1 to be a part of the problem. I don't want that to be the part of the problem for the reasons that are obvious essentially, for the reason that B1 and C1 they don't work with K or H prime. So the definition of point D right now is kind of like very distant from defining point K, which is not very nice because we kind of need the segment DK. Um, yeah. Okay. I don't know how to redefine point D. I mean, we can probably draw a line DN. Intersecting this will point would be the C median point. That's probably better. Mm, But we have a ratio 1 to 2 here, so it gives vibes of centroid, to be fair. Um, we do need a line that's parallel to H prime K for sure, for the ratios. Okay, so it's obviously either A1, either N. This doesn't pass through anything nice. This. Oh, yeah, yeah, yeah. Okay, okay. Okay, we are over with the hardest part. If we take the centroid of triangle ABC, yeah, this is nice, this is nice. If we take the centroid of triangle ABC, point G, by Euler theorem, Hg to Go is 2 to 1, and therefore, if this is 2, this is 1, this is 3, then Hg to Gh prime is 1 to 2, and this is 1 to 2, so Ga1 is parallel to H prime. Okay, and now we can kind of get rid of this segment, right? And say, okay, let us take the centroid, and we know that the centroid will be here. This is our centroid, point G. And actually, for the people that are like pretty good at geometry, it's not it's not only that we got rid of line the H prime K that makes us happy. The other thing that makes me really happy right now, yeah, it's not the fact that it's still summer and I can do whatever I want. It's the fact that line GA1 is not a very like, random line. This line actually passes through a point. I usually call this point T on the circumcircle such that AT is parallel to BC. It is true that A1, G, and T are collinear. You can prove that. I guess I won't waste your time on showing this. I think there's multiple approaches to do that, and I don't find it pretty. I don't think it's worth my time to be explaining this. But the easiest way is to reflect. Okay, I will explain it. Oh my goodness. If is reflecting T about M, and noticing that this point is the reflection of A about BC, and then for this triangle here, G is the point of intersection of two mediums, and therefore it's 2 to 1, 2 to 1. Okay, happy. If you didn't get it, just scroll back, look at the diagram, and realize why it's true. Okay, we have this. So we need to prove that this line is perpendicular to DK. The other thing about DK is like, I don't like DK either. Like we fixed line h prime k, and now we need to fix line dk because dk is a very, very bad line. It doesn't work well with point D because point D is defined very, very differently. So what can we do? We can either draw parallel line or reflect the line. I don't think parallel line works anywhere, but when I'm talking about reflection, why I talk about reflection is because this line, it can easily be reflected about BC. So what I'm talking about is reflecting A1 about M, getting a point that we call A1 prime. And for this A1 prime point, we do know that this is true. Well, that's pretty obvious. However, the thing that actually interests me right now is that this line here, which I'll call AA1 prime, and we'll mark this line red. This line is reflected is reflected about BC is parallel to the line GA1, and this line, the blue line that we want to prove that is perpendicular to this line, if we reflect it about BC, it's the same as reflecting A1 about H, getting point, let's call it X, and then showing that dx is perpendicular to the red line. That is essentially absolutely the same. And this is blue. So because they were reflected, these two should be reflected. And now we do see a very cool thing. And this very cool thing is called triangle ADA1 prime. For this triangle, oops, I just make it black and thinner. Ooh, that's too thin. That's better. So for this triangle, x such a point that dx should be perpendicular to AA1 prime. But besides that, AX is perpendicular to A1 prime D, so X must be the orthocenter of this triangle, which means that is enough to show that A1 prime X is perpendicular to AD. Okay. Wow. 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 Okay. XH equals HA1 and A1M equals MA prime 1, so XA1 prime is parallel to HM, and HM where you showed is wow. Oh, this is nice, man. This is a nice question. Yeah, this is a great question. I loved it. Thank you for Simmons 2006 for proposing it for me to solve. I enjoyed this. I rarely spend so much time on a question, and that like with a new construction as well. So I've never seen this construction before, and it's quite nice. So thank you again for proposing this question. Let me know what do you think about this video. Uh, and if you want it for me to discuss any problems, just mention in the comments and I'll do it. Yeah, and yeah, thank you guys. Again, thank you so much for the support. Thank you for all the nice comments. And I love all of you guys. And thank you for subscribing. And I'll see you soon. Thank you guys.